Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Synchronous data transmission system. In this module, we are going to study about the introduction, difference between synchronous and asynchronous, types of synchro, and types explanation. Introduction. Synchronous transmission synchronizes transmission speed at both the receiving and sending end of the transmission using the clock signal. The clock may be a separate signal or embedded in the data. A continuous stream of data is then sent between two nodes. Due to there being no start and stop bits, the data transfer rate is more efficient. Have a glance at this difference between synchronous data transfer and asynchronous data transfer. There are several points which differentiate them. Synchro systems are divided into four main categories as follows. Torque. This is the simplest form of synchro in which the torque is derived solely from the input to its transmitting element. No amplification of this torque takes place. Moderate torque is only developed at the output shaft of the receiving element, and for this reason the system is used for data indicating purposes, example oil or 135-136 fuel pressure, and for the indication of the position of mechanical controlling devices, example airflow control valves. Control. This type of synchro normally forms a part of the servo mechanism to provide the requisite signal which after amplification are used for the control of a drive motor. Resolver. This is used where the precise angular measurements are required. It converts voltages which represent the Cartesian coordinates of a point into a shaft position and a voltage which together represent the polar coordinates of a point. They can also be used for the conversion from polar to Cartesian coordinate. Typical applications are in the analog computer, remote indicating compasses, and flight director systems. Differential. This type of synchro is used whether necessary to detect and transmit error signal representative of two angular position. Such a manner that the difference or the sum of the angle can be indicated. They can be utilized in a conjunction with either torque control or resolver synchro system. Have a look at this diagram of synchro types, their abbreviation, circuit, and symbols. Torque synchro. When the TX and TR rotors are in the same angular position, example the electrical zero position, the voltages induced in the stator are equal to the opposite, and so the no current will flow in the stator coils. If however the rotor occupies different angular position, example the TX rotor is moved through an angle of 30 degree while the TR rotor is at electrical zero, then an unbalanced condition between voltages induced in the stator coil arises. When the TR rotor synchronizes with the 30 degree position of TX rotor, its field will be in alignment with the resultant field and its voltages will be balanced and current no longer flows between the stator. The system is then said to be at null position. Control synchro. Produce an error voltage signal in the receiver element and the rotor winding is on the cylindrical core to ensure that the rotor is not subjected to any torque when the magnetic field of the CT stator is displaced. It operates as a single phase transformer with the stator winding acting as the primary and rotor winding as the secondary. The stator winding coils are of high impedance to the limit of alternating currents through them. Single phase AC power is connected to its rotor only. It is at electrical zero when the rotor is at 90 degree. With the rotor at electrical zero position of 90 degree, the induced voltage is zero. Differential synchro. In some applications, it is necessary to detect and transmit error signal representative of two angular position, and in such a manner that the receiver element of the synchro system will indicate algebraic difference or the sum of the two angles. Also has three star connected winding and rotor core of the cylindrical shape. Also has three star connected windings and the rotor core is of cylindrical shape. For detecting the algebraic difference between two inputs. Resolver synchro. Resolver are employed to convert Cartesian coordinate of the into the shaft position and a voltage which together represent the polar coordinates of a point. Let us now see what it means by these terms and how they are related to a voltage. Null position, that is at 90 degree. Synchrotel. A synchrotel is generally used as a low-torque CT, stator core carrying 3 windings at 120 degree apart, measurement of fluid pressure. Synchrotel rotor is connected to appropriate pressure sensing element. The CT rotor is energized by 26 volt 400 Hz single-phase AC supply which induces voltage in its stator. Since the stator is connected to the synchrotel stator, then a resultant radial alternating flux is established across it. When no voltage is induced in the rotor winding, that is, the CT is driven into the null position. This was all about the synchronous data transmission system. Thank you.